Okay, so we're going to look here about spreadsheet models, which is covering chapter 7. So for an introduction, spreadsheet models are mathematical and logic-based models. They're referred to as what-if models. They provide easy-to-use, sophisticated mathematical and logical functions. They allow for easy instantaneous recalculation for change in model inputs. They are less expensive. They often come preloaded on computers. They're fairly easy to use, and they're the most basic or most used business analytics tool out there. So building good spreadsheet models. We're going to use influence diagrams. We're going to look at building a mathematical model and then spreadsheet design and implementing the model in a spreadsheet. So for building good spreadsheet models, this is going to be kind of examples out of the book. So the total cost of manufacturing a product is the sum of two costs. First, we have a fixed cost. This is the portion of the total cost that does not depend on the production quantity and remains on the same no matter how much is produced. Then we have a variable cost, and this portion of the total cost that is dependent on and varies with the production quantity. Now, this is a make versus buy decision. So we're going to compare the cost of manufacturing in-house to the cost of outsourcing production to another firm. And we're going to use the example in the book, the Nolan Plastics, and they produce a line of cell phone covers. Now, Nolan's best-selling cover is its Viper model. It's a slim but very durable black and gray plastic cover. Now, the annual fixed cost for the Viper is $234,000. So that's the fixed cost. Now, this fixed cost includes management time, advertising, and other costs that are incurred regardless of the number of units eventually produced. In addition, the total variable cost includes labor and material costs, and that's $2 for each unit produced. Now, Nolan is considering outsourcing the production of some products for next year, including the Viper. Nolan has a bid from an outside firm to produce the Viper for $3.50 per unit. Although it is more expensive per unit to outsource the Viper, $3.50 versus $2, the fixed cost can be avoided if Nolan purchases rather than manufactures the product. Now, the exact demand for Viper, though, for next year is not known. So Nolan would like to compare the cost of manufacturing the Viper in-house to those outsourcing its production to another firm, and the management would like to do that for various production quantities. And now many manufacturers face this type of decision, and like we said, it's the make versus buy decision. So we're going to look at influence diagrams. It's a visual representation that shows which entities influence others in a model. And part of the model are represented by circle or oval symbols called nodes, kind of like we had decision nodes in the last chapter. Now we have just these nodes. And the arrows connecting the nodes show influence. Okay, so this is an example, figure 10.1, and it's in our book. And it's an influence diagram for Nolan's manufacturing costs. So we have all these arrows pointing to the different items. And the total manufacturing cost, which is our top part here, depends on fixed cost and variable cost, which in turn depends on the variable cost per unit and the quantity required. So we have the total manufacturing cost are made by the fixed cost and the variable cost. Now these variable costs are made up of the variable cost per unit as well as the quantity required. So each one of these lines goes up to a point, and then our final node up here is the total manufacturing cost. Okay, here, this shows an expanded influence diagram that includes an outsourcing option. And so we have total manufacturing costs, which are fixed and variable, and then we have our outsourcing costs. So we have that added in there. Okay. Now, note that the influence diagram in 10.1 is a subset of the influence diagram of 10.2. So we can kind of see that this is part of it, but then this quantity required kind of goes to both sides, also goes to the total outsource cost as well as that variable cost here. Okay. So now let's move on to figure 10.3. Now this shows a spreadsheet model for the Nolan Plastics make versus buy decision. Oh, whoops, I'm not going reading ahead here. So here we're going to first need to build a mathematical model for this. So first we're going to consider the cost of manufacturing the required units of the Viper. As the influence diagram shows, this cost is a function of the fixed cost and the variable cost per unit and the quantity required. Now we're going to define the notation for every node in the influence diagram. We're going to have the Q, which is going to be the quantity or the number of units required. The FC is the fixed cost of manufacturing. The VC is a variable unit cost of manufacturing. The TMC is the total manufacturing cost for Q units. Then we have the cost volume model for producing Q units is, for that total manufacturing cost, it's the fixed cost plus variable cost times the number of units. And so for the Viper, we have the fixed cost equals 234,000, like we mentioned. The variable cost was $2 for each unit produced. So the TMC of Q is 234 plus 2 times Q. So whatever units we produce, that's going to be multiplied by 2 and then added to our fixed cost. So the mathematical model for purchasing Q units is TPC of Q equals P times Q, basically. Okay, P is the purchase unit, the per unit purchase cost, and the TPCQ is the total cost to outsource or purchase Q units. Okay, so for the Viper, they said it was $3.50 per unit. So the P is going to be $3.50, and then we just have to multiply that by the Q to get our total purchase cost. All right. Now here the mathematical model for the savings associated with outsourcing. So if we outsource, it's supposed to be cheaper. And so what is the savings? Well, the savings SQ is equal to the TMC, total manufacturing cost, minus the total, the production cost, and so savings is going to be due to the outsourcing. So no one has to decide for what quantities is it more cost effective to outsource rather than produce the Viper. And for those who want to look at it mathematically, is for what values of Q is S of Q greater than 0. Okay. So for the spreadsheet design and implementing the model in the spreadsheet, for the Nolan Plastics problem, we've already defined the following components. So we've defined all of those already. And the TMC, the TPC, and the S are the functions of the other components, whereas the Q, FC, VC, and P are not. So those are kind of like fixed, or we're trying to decide what one it is, like as far as Q goes. Now the TMC, TPC, and S will be formulas involving other cells in the spreadsheet model, where those four here, the Q, FC, VC, and P, are just going to be entries in the spreadsheet. So they're just going to be a single entry. If we do it like a table, it's going to have Q equals, and then it has a number, FC equals 234,000, for instance, and so on. So the number of Vipers to make or buy for next year is really a decision no one gets to make. Hence, we refer to the quantity Q as our decision variable. Now, FC, VC, and P are measurable factors that define characteristics of the process we are modeling. Hence, we refer to FC, VC, and P as the parameters. And that's going to usually be in the top part of our spreadsheet model. And so this is going to be our spreadsheet model. And then, so this is our Nolan Plastics make versus buys spreadsheet. And so our parameters are going to be up here in the top part: manufacturing fixed cost, manufacturing variable cost per unit, and the outsourcing cost per unit. So that's going to be our parameters, like I said. All right, so another thing we're going to do is always for column A, that's reserved for labels. So we don't want to put any numbers in column A. That's just, we're going to try to make these spreadsheet models as clean as possible so we don't have a really messy one to try to read. So those in column A are going to be reserved for the labels. Okay, and since this is Nolan Plastics, that's the title of it. And then we have the parameters, the model, our different parameters, and then the model items here. All right, so the input parameters are going to be, like I said, the manufacturing fixed cost, the manufacturing variable cost per unit, and the outsourcing cost per unit. And we offset P from FC basically, and VC because it's for outsourcing. So we're kind of moving this down here a little bit. We're not putting it right up there because that's going to be an outsourcing instead of an actual in-house cost. And then after that, we have our model section. Like I said, the first entry is going to be our quantity Q, okay, and which is the number of units Viper produced or purchased in cell B11. So this is going to be B11. That's going to be how many we purchased or outsourced. And again, these are just going to be the values here for the actual manufacturing fixed cost, that variable cost per unit, and the outsourcing cost. All right. Then what we are doing now is going to be putting in the equations for each one of these here. So the TMC, we just take the FC plus the VC times Q. The TPC is just P times Q, so the P times Q. And our SQ is going to be just the TMC minus the TPC, so just the difference between those two. So those are going to be how we do our calculations, and it's real simple. We just type equals, and then we click on the cell B4 plus then the cell B11, and then times the cell B5. And so we don't want to put any hand type variables or numbers in here, because what happens is if we want to change something later, we actually have to go through every single equation in our model, and we might have pages and pages of models to make. And so we just want to make it as simple as possible by referencing other cells. Okay. All right, so here what we do is after we type in our 10,000 and we hit enter, we get our values here. And so the total cost to produce is going to be 254,000. The total cost to outsource would be 35,000. And so the savings due to outsourcing those 10,000 units is going to be 219,000. So that's going to be what we save. Now, what we have to do is we have to go through all this and figure out, okay, well, what about 20,000? What about 30,000? What about 40,000? And that's kind of the trial and error approach. And really, we don't want to use that because it's going to take a lot of time. So luckily, Excel has a what-if analysis tool that's going to help our model to further analyze the problems. So the general principles of spreadsheet model design and construction are: we're going to separate the parameters from the model, like we've done before. This enables us to, the user, to update the model parameters without the risk of mistakenly creating an error in the formula, kind of like I said. Also, it's going to document the model and use proper formatting and color as needed. So we highlight and make this blue because that's going to be the value we change. So we're changing it from the 10,000, maybe next time we put in 30,000 or whatever. And so we'll highlight things that we're going to be changing, okay? So and then we want to make sure I have clear labels and proper formatting and alignment to facilitate navigation and understanding. And we want to use simple formulas. Clear, simple formulas can reduce errors, make maintaining the spreadsheet easier. And if you have a long and complex calculation, it should be divided into several cells. And that's kind of what we've done here, because we could have really got this savings due to outsourcing in one cell, but we would have had put all these calculations into one cell, and we wouldn't actually see them split apart, as well as we could make a mistake somewhere along the way and we wouldn't really notice that as a whole there. Okay. So what if analysis? We have data tables and we're going to look at goal seek. All right, so data tables. Excel tool which quantifies the impact of changing the value of a specific input of an output of interest. We have a one-way and a two-way data table. The one-way summarizes a single input's impact on the output, and a two-way summarizes two inputs' impact on the output. Okay. Now let's consider savings due to outsourcing changes as a quantity of Viper covers or changes. So this should help us answer the question, for which value of Q is outsourcing more cost effective? So the one-way table, changing the value of the quantity and reporting savings due to outsourcing would be very useful. And what we're going to do is we're going to use the previously developed Nolan spreadsheet for this analysis. So in this slide 17, we see the input for constructing the one-way data table for Nolan Plastics. And so this part we already had, A and B. Now we're going to add in columns D and E. So the first step into creating a one-way table is to construct a sorted list of the values you would like to consider in the input. Okay, so that's going to be the quantities. That's our Q values. And so let's say we want to go from 0 to 300,000 in increments of 20,000 units. So that's what we've done. We've kind of typed all those in. That's the ones we're going to look at. And so these are going to be basically the values that Excel is going to be using as inputs for Q here. Okay. Now, since the output of interest is savings due to outsourcing, we have to enter the formula D17 into E4. Okay, so this one comes up here to E4. So that's going to be our savings. Okay. So in general, the cell to the right of the label to the cell location of the output of interest. So the quantity and then our output interest is our savings. And so then we're going to kind of see how the savings go as we go along. All right, so what we have to do is we're gonna, for the basic structure, once that's in place like we have here, we're gonna invoke the data table tool using the following steps. So we're gonna select the D4 all the way up to the E17. Then we're gonna click the data tab in our Excel ribbon. Then we're going to click the what if analysis in the data tools group and then select data table. Now when the data table dialog appears, and what we're going to do is we're going to enter in box B11 in the column input cell. Okay, so that's our B11. So that's kind of what goes in there. Then we're going to click OK. So then what happens is we get this. Because we've kind of told it what to do, now in figure 10.5, the table is populated with the values of savings due to outsourcing for each value of the quantity of vipers in our table. So, you know, we set the quantities and set 0, plugs in 0, gives us a savings of 234,000. Plug in 25,000, and it gives us a savings of 196,500. Okay. So once we get down here to the negative values for saving due to outsourcing, that means manufacturing in-house is actually going to be cheaper than outsourcing. So all these values that are in the negatives, it's cheaper to do in-house than outsourcing. Okay, so what we really know is 150,000, it's still positive, so it's cheaper to outsource. 175,000, it's more expensive to outsource, so it's cheaper to manufacture in-house. Okay. So we can provide that information to the management and they can decide what they want to do with it after that. But okay, suppose that they receive 5 different bids though, instead of just that one $3.50 bid. They've received 5 bids on the per unit cost for outsourcing the production of the Viper. So really the lowest bid usually provides the greatest savings. Okay. However, the selection of the outsourced firm, if Nolan decides to outsource, will really depend on many factors, including the reliability, the quality, on-time delivery, as well as that lower cost. So it would be instructive really to quantify the differences in savings for various quantities and bids. Now the 5 different bids that they got were $2.89, $3.13, $3.50, $3.54, and $3.59. So we're going to use the data table again to construct a two-way. So this is going to be the two-way. Okay. Table with a quantity as a column and the 5 bids as a row, as shown here in figure 10.6. So that's the quantity and that's the cost per unit. Okay, so this used to be the cost per unit, but now we've got 5 bids now and we want to test those bids. So what we're going to do is we've entered the various quantities in cells D5 through D17. Okay, D5 right here through D17 that we want to do as the one-way table. And these correspond to basically our one-way table in the cell B11 in our current model. So whatever value that is here. Now in cells E4 through I4, these are going to be the bids and they're going to be the outsourcing costs. So what we're going to do in cell D4 above the column input, values, and to the left of the row input values, we have entered the formula equals B7. Okay, and so that's going to be the row input cell B7. Okay, well, yeah, so that's going to be the row input cell. Let's see, how did I say that? In cell D4. Oh, so yeah, this is B17, sorry. Instead of having our quantity here, we've put the savings at that point here. Okay, so that's what we did. I was reading what I was doing wrong here. Okay, so what happens once the table inputs have been entered into the spreadsheet, we can perform the following steps as shown in our book. We're going to first select D4 through I17. So we're going to select that whole blue section. We're going to click the data tab in the ribbon of our Excel. We're going to click the what if again in the data tools, and we're going to select data table. And then when in the data table, the dialog box here appears, the data table. We're going to enter B7 into the row input. Okay, B7 is this, and that's what goes into here. And then B11 in the column input cell. So B11, which is going to be our quantity that goes here. And then we're going to click OK. And then figure 10.6 shows the selected cells in the table dialog box here. So that's what's going to all happen. And then when we go over here, this is what the output is. So it's going to fill in all of this data here. Okay, and as you notice, as we go down, things change depending on which cost is different. Okay, so 0, that's our basic $234,000 manufacturing fixed cost. And then once we start having 25,000, we can see the differences based on the different unit prices. And then we can see, okay, well here we can make up to 250,000 outsourcing before we could go over to 275, where it's cheaper to do in-house. Whereas here we can only go to 200,000. Here we can only go to 150,000, 150,000, and here 125,000. So kind of things change a little bit there, as far as depending on where our quantity changes, depending on our unit prices here. Okay. All right. So let's see here. What do I want to say else about this? So that gives us kind of a breakdown, but sometimes there are more things we need to do. So what we're going to do is we're going to do a what-if analysis. We're going to do a goal seek. And this is an Excel tool that allows the user to determine the value of an input cell that will cause the value of a related output cell to equal some specified value, which is our goal, which is that it's greater than 0. So in the case of Nolan Plastics, suppose we want to know the value of the quantity of Vipers where it becomes more cost effective to manufacture rather than to outsource, okay? So let's say here, for example, we see from the table and figure 10.7 that for a bid price of $350, which you have here, and some quantity between the 150 and 175,000 units, the savings is going to happen somewhere in there due to outsourcing, because it goes from positive to negative. Now, somewhere in this range, the savings due to outsourcing is 0, and that's where the point Nolan needs to be indifferent to manufacturing and outsourcing. So that's where the kind of that split. Which one do we do? Go up or down? And so that's going to be what we're going to be using with our goal seek, is kind of figuring that what that exact point is where it becomes more cost effective. Okay. And so this is going to be the goal seek function, and this is our dialog box for it. And so, like I said, we're going to use the goal seek to quantify the number of Vipers that satisfy the goal of 0 savings due to outsourcing for a bid price of $3.50. And that's the one we're going to worry about right now. You can do it for all of them, but this is one we're going to look at now. So the following steps are going to be done. So we're going to click Data tab in the ribbon. Then again, we're going to click the What Ifs in the Data Tool group and select the Goal Seek. Now, when the Goal Seek dialog box appears as shown here, and we're going to enter B17, which is going to be our savings, in the set cell. So we're going to set that cell, and what value we want to have it, that's going to be set to 0, because that's where we want the kind of that break-even point. And what we're going to do is we're going to change the B11, the quantity. So that's kind of all we're going to do. We're just going to change the quantity and try to get the B17 to equal to 0, and then we'll find out what value is going to be our best, okay? And when we do that and say go, it says, well, we got 156,000 is going to be our goal, okay? So, and it tells you the goal seeking with cell B17 found a solution, the target value of 0, and the current value is 0, and that's at 156,000 units. So when the annual quantity reached is, or required is 156,000, it costs 564,000, we can see, or 546,000, to either manufacture or to produce it. They both are the same, okay? So to produce and to outsource cost the same. Okay, so any value beyond that 156,000, it becomes cheaper to manufacture in-house. Any value below 156,000, it's cheaper to outsource. So that's kind of our point where we go one way or the other. All right, so some useful Excel functions for modeling. We're going to use the sum product, if, COUNTIF, and VLOOKUP. So those are the different functions we'll be using here. So for the sum and sum product, the sum basically is just the function that adds up all the numbers in the range of cells. So you're going to say equals sum, highlight a section of cells, and hit enter, and it gives you the sum. Now the sum product is going to be a function that returns the sum of the products of elements in a set of arrays. So basically it's going to take one value in one array, multiply it times the value in the other array, and give you all of them multiplied together and give you a sum product, okay? So here, let's consider a transportation problem faced by Foster Generators. This problem involves the transportation of a product from 3 plants to 4 distribution centers. Now, the production capacities for the 3 plants over the next 3-month planning period are known. Foster has forecasted demand for the 3-month period for each of the distribution centers. Then the per unit shipping cost from each plant to each distribution center is also known. And what management would like to do is determine how much of its production should be shipped from each plant to each distribution center. And so we have this kind of complicated, more than what we've seen before, what if model for Foster generators. Okay, so this is going to be our destination: Boston, Chicago, St. Louis, or Lexington. This is our origin: Cleveland, Bedford, or York. And so that's going to be our values, okay? So to minimize the cost, the capacity at the plants must not be exceeded, and the forecasted demand must be satisfied at each of the 4 distribution centers. Now the parameters section is rows basically 2 through 10. So we can see parameters, so it's 2 through 10. And basically they're just leaving some blank spaces here, but they call it row 2 through 10 in case we need to add something later. Now cells B5 through E7, which are right there, those are going to contain the per unit shipping cost from each origin or plant to each destination. So basically it's going to cost to ship from Cleveland to Boston $3 or 3 unit, the unit cost per shipping, okay? So it's that much per generator, I guess you could say. And so then the plant capacities are given in cells F5 through F7. So F5 through F7, that's going to be our plant capacities, okay? And the distribution center demands appear in cells B8 through E8. And so that's going to be these values here. So B8 through E8, that's going to be our demand. So the model now is going to be rows 11 through 20. So our model is going to be all the way down here, okay? All right, so the trial values of shipment amounts from each plant to each distribution center appear in the shaded cells B17 through E19. So that's going to be this value here. These are the trial values of shipments. Okay. Now the total cost of shipping for this proposed plan is calculated in cell B13. Okay, so that's right here. And that's going to use our sum product function. So this is one of our functions we said we're going to use. Now the general form of the sum product is going to be sum product of array 1 comma array 2. And what we have is array 1 is going to be maybe all of these cells, and array 2 are going to be all of these cells. And so that's what we're going to be doing here. So the function basically pairs each element of the first array with its counterpart in the second array, multiplies the elements of the pair together, and then adds them together to get our final result, the sum product. Okay, so in B13 there, what we can see is we have the sum product of B5 colon E7 comma B17 to E19. And basically all it is, like I said, it's just B5 through E7 and then comma the B17 through the E19, okay? And so what it's going to do is take B5 times B17 plus, and then C5 times C17, D5, D17, and so on. And then after it gets all those products all done together, it's adding them all together. And so that's going to be what shows up in here in the total cost, okay? Now that's using sum product. Now if we're going to use the sum in F17 through F19 over here, we can use the sum. We can also use it down here in the B20 to E20. And what we're doing is we're taking the sum of this row, the sum of this row, sum of this row, and here we're taking the sum of this column, sum of this column, sum of this column, and sum of this column. And that's just to get us an idea of what our values are there, okay? So once we type all those in and hit enter, then we get our table to look like this. This is kind of our output, okay? And so basically the only thing really we found was it's going to have a total cost of the $54,500. It gives us our sums here, which we can read. And again, these are all in our book as far as figure 10, so you can look in that and see what they are there, okay? Some other functions we can use, if and COUNTIF. So if, and then it's going to give you a condition, the comma, results of the condition is true, comma, result of the condition is false. So basically you have to tell it something, and then if it's that something is true, it gives you this answer. If it's false, then it gives you this answer. Okay. We also have a COUNTIF, and it gives us a range. So we select a set of data, and then we give it a condition. So we're going to count that range if it meets some condition. So the counts the number of components having a positive order quantity, for instance, in this case, or count it if it's equal to 1. If you're doing a list of items that are 1 or 2, you can count the number of ones in a list of 10,000, and it just gives it to you right away. Okay, so illustration, Gambrill Manufacturing produces car stereos. Gambrill likes to keep its components inventory to a minimum. Hence, it uses an inventory policy known as order up to policy. Now, the order up to policy, whenever the inventory on hand drops below a certain level, enough units are ordered to return the inventory to that predetermined level. Okay, so, and this is because stereos are composed of a variety of components that the company must carry in inventory to keep the production running smoothly. So with the order up policy, if the current number of units in inventory is denoted by H and it drops below some level M units, enough inventory is ordered to get the level back up to M units. Okay, so M is called the order up to point. And so what we're doing is we're going to kind of define these values so we can see that what it is in the next slide. So M is the order up to point. And so mathematically, if Q is the amount we order, then Q is going to be M minus H. Okay. And so that's going to use what we're going to do in some of these cells here. So this is figure 1011 in our book, the Gambrill Manufacturing Component Ordering Model. And so if the upper half of the worksheet, again, we see is going to be our parameters. Okay. And so we have the component ID, we have the inventory on hand, order up point, cost per unit, and the fixed cost per unit, minimum order size for discount, and it's discounted to what? Okay, discounted to what? It's discounted to the 90%, so we're getting the discount of 10% off. And then these are going to be our different component IDs. Okay, now this is only showing 2 of them. We actually have 4 in our final table, but what we've done is they've spread it out so you can actually see the full equation instead of just little bitty pieces here, which end up being just the numbers. Okay. So in that upper half of the worksheet, the component ID number, inventory on hand, which is our H, the order up point M, and the cost per unit are given for each of the 4 components. Also given in the sheet is the fixed cost per order. Now in this case, it's $120. So it's incurred whenever an order is placed, regardless of how many units are actually ordered. And the model portion of the worksheet calculates the order quantity for each component. So depending on the number of units ordered, Gambrill receives a discount on the cost per unit. Now, if more than 50 here, minimum order, if it's more than 50 are ordered, there's a quantity discount of 10% on every unit purchased. For example, for component the 741 here, the unit cost is $450 and 95 units are ordered. Because 95 exceeds the 50 unit requirement, there's going to be a 10% discount. And the cost per unit is reduced to $450 minus 0.1 times $450, or $450 minus 0.45, which is going to give us the $405 value. And then if we multiply that out, we're going to get 405 times the 95, which is going to be 384.75. So that's going to be what we're going to use. Although I think I wrote the wrong number down there. It should be this one instead of this one, okay? Because that was the one with 95. All right, so that's going to be how that works. Now, the Excel function used to perform these calculations are shown in figure 1011, as I said. Now, the if function is used to calculate the purchase cost of goods for each component in row 17, okay? So if B16, which is this value, is greater than or equal to B10, which is this value, and we're putting the dollar signs so we don't, if we copy down or copy to another cell, it's not going to change anything, because what we can do is once we have this, we can copy over to this column, and we can copy over to the next column and to the next column, and all it does is it changes what this value is, the B16. So it'll copy it over, and then it'll make it to the C16, and if you copy it to the next one, it'll be the D16, okay? And so if B16 is greater than or equal to B10, then comma, B11 times B6. Otherwise, it's just B6, okay? So if it is going to be greater than 50, we're going to take B11.9 times our B6, which is the 4.5, and that's going to be our new value. Otherwise, it's just going to be the B6 value here, Okay, it's just going to say, okay, otherwise, if it's not greater than 50, we're just taking 4.5. And then we're going to multiply the whole thing times B16. And similarly here for the C's. And so that's what we have. All right, so now with the COUNTIF function, basically we're just going to count the B16 to E16. So all these values, B16 all the way over to E16, probably be better here. And we're going to count them, and we're going to say if they're greater than 0, we're going to count it, okay? So greater than 0, those two are greater than 0, that's greater than 0, so that's going to be the values there. So that's what the COUNTIF here is for 19, okay? So 3 of them. All right, so then let's see here. What else do we have? Then we just have the total fixed cost. So then we just take the B19 times the B8, which is the fixed cost per unit. The total cost is going to be the sum, so we're going to use our sum again. And the total cost here is going to be, again, a sum. So we just have to put in this proper values as far as which cells they're in. And then we just say the sum going from here to here or here to here, depending on the cost of goods or the total cost. And then it just fills all this all the things in for us, okay? Now, VLOOKUP is another useful, and this function allows the user to pull a subset of data from a larger table of data based on some criterion. So the general lookup formula is VLOOKUP equals some value, comma, the table it's in, comma, the index, comma, the range. And so the value is the value to search for in the first column of the table. Now the table is the cell range containing the table, so that's pretty obvious. Index, now this is the column in the table containing the value to be returned. And then we have the range. It's true if looking for the first approximate match of value, and false if looking for an exact match of a value, okay? So this is kind of how we're going to use this. All right, so as shown in cell E3, so over here, the bonus pool is $250,000 for this year. So this is what the parameter is, bonus pool, $250,000. Now the bonus bands are in cells A7 through C11, okay? So these are going to be our bonus bands. In this column, in this table rather, column A gives the lower limit of the bonus band, column B gives the upper limit of the bonus band, and column C is going to be the bonus points awarded to anyone in that bonus band. So if they're in this bonus band, they get 0, here they get 10, 15, 25, and 40 if they're in this band. So for example, people who achieve 56% above their sales target would be awarded 15 points, okay? So that's going to be in this 51 to 79. That's going to be 15 bonus points, okay? Now, the name and percentage above the target achieved for each salesperson appear below the bonus band table in columns A and B, okay? So that's going to be down here. Now in column C, the VLOOKUP, this is going to be how we do the bonus points, okay? Is going to be used to look in the bonus band table and automatically assign the number of bonus points to each salesperson. And the VLOOKUP assumes that the first column of the table is sorted in descending order. So if this is not in ascending order, then we're going to be in trouble because it assumes we are. And then the VLOOKUP function for salesperson, let's say Choi, that's going to be over here in C18. And it's going to be VLOOKUP is going to be B18, comma, the A7, and we're going to put the $sign around those because that's going to not change. We don't want it to change. And then colon to C11, okay, so all the way over here. So that's kind of our table we're looking in, okay. And we're going to look for 3, and then we're going to look, that's going to be the next thing, comma 3, and then comma true, okay. And now this function uses a percentage above target sales from cell B18 and searches the first column of the table defined by the A7 through C11, this table up here. Okay, because the range is set to true, indicating the search for the first approximate match, Excel searches in the first column of the table from the top until it finds a number strictly greater than the value given in B18. So B18 is 44%, and the first value in the table in column A that's larger than 44% is going to be that 51%, the 0.51. Okay, then what it does is it backs up one row, goes back up here, and that's in row 8. And because 3 is in the third argument of the VLOOKUP function, it takes the element in row 8 of the third column. Okay, so we know that it has to be right above it, and then we go all the way over to the third column, and it's going to give it 10 bonus points. Okay, so basically we're just looking down the first one, and the first first one over 44 is the 51. What it does is it goes up one row one row one row above the 0.51, and then because we said we are going to take the value out of the third column, it goes over to the third column and says, okay, that's a 10, and so then we get that, and then it plugs in our 10. Okay. All right, and that's what it gives us down here. This is the 10. Okay. So in summary, the VLOOKUP with range set to true takes the first argument and searches the first column of the table for the last row that is strictly less than the first argument. Then it selects the row, the element in the column number in the third argument, and then once all the salespeople are awarded bonus points based on VLOOKUP and the bonus span table, the total number of bonus points awarded is given in cell C30 using the sum function. Okay, and so we just use the sum and we find out it's 295. Okay. And so that's kind of what we're doing. And then these are just the percent of pool. It's just the one number divided by another, and these are multiplied. And so that gives us the bonuses, a percent of the pool, and the values. And so that comes all based off of this VLOOKUP. So it plugs it in automatically, and then all those come in because we've set the equations. And then once this happens, then those all automatically fill in. So the next thing we're going to do is look at auditing spreadsheet models. We're going to look at trace precedence and dependence, show formulas, evaluate formulas, error checking, and watch the window. All right, so auditing spreadsheets. Excel contains a variety of tools to assist you in the development and debugging of spreadsheet models, which is really nice. Now, these tools are found in the Formula Auditing group of the Formulas tab. Now, the trace precedence and dependence. Now, if we have the trace precedence button, after selecting cells, this button creates arrows pointing to the selected cell from cells that are part of the formula in that cell. Trace dependence button shows arrows pointing from the selected cell to cells that depend on that selected cell. And both of these tools are excellent for quickly ascertaining how parts of a model basically are linked together. Okay. And so this is our formula auditing group. So we have trace precedence, trace dependence. Sometimes once we get the arrows in there, we want to remove the arrows, so we can do that. Shows the formulas, we do error checking, and we can evaluate the formulas. So this is all going to be in the formula auditing. All right, so this is trace precedence for Foster generator. Okay, so here we have opened the Foster generator's Excel file basically, and we've selected cell B13. Okay, so B13, that's our total cost. And we click the trace precedent button in the tab before. So trace precedence, we've clicked that. And what it does is B13 is calculated as the sum product of the per unit shipping cost and shipping units. So it's basically saying, okay, well, this total cost comes from this set of numbers and this set of numbers. So it kind of highlights them and says it goes here, highlights around it and says it goes here, okay? And so those arrows are showing where it's going from and to. The circles start and then arrow goes to, okay? And then once we are done with that, we can remove the arrows. Okay. Now, same thing with trace dependence. What we can do is, in this case, select cell E18, okay? And what we're going to do is, this is the unit shipped from Bedford to Lexington, and we click on the trace dependence button again. And now, what's dependent on this value? Well, this total here is, which is the sum. This sum is also dependent on it, as is that total cost. And so this shows, you know, what this one single value affects in the model here. Okay. And again, we can remove the arrows if we want to, and that's not a problem. So let's see here. So the next thing is we can show formulas. So to see the formulas in a worksheet, simply click on any cell in the worksheet and then click on the show formula, and you're going to see the formula residing in that worksheet. And that's how we go about, now I'll probably lose where 37. And that's how we go about showing these. You can use the show formula, and that's what we're doing here. And all we can do here is just, you know, do the clicking on it, and it'll actually show us that formula. Okay. Now to revert to hiding the formulas, click again on the show formula button, and it's going to disappear. Now, evaluate formulas. Now, the evaluate formulas button allows you to investigate the calculations of a cell in great detail. It provides an excellent means of identifying the exact location of an error in a formula. Okay. So here the evaluate formula dialog box comes up here. And so an example here is, let's investigate our B17 at 384.75. Okay. And now remember, what we're doing is we're calculating the cost of goods based on whether there is a quantity discount. So what we're going to do is we're going to select that B17, and then we're going to click the formulas tab in the ribbon, click the evaluate formula button in the formula auditing group. Now when the evaluate formula dialog box appears, which is again this box here, click the evaluate button. Okay, that's just this button right here. We're going to click that. And then we're going to repeat that until the formula has been completely evaluated. And then we're going to click close. And so that's how you keep evaluating it. Just keep clicking it until basically the whole formula is evaluated. So it's just going to do pieces and pieces and pieces until it's completely done. And then once it is, then we can kind of see what happened along the way. All right. So this is our evaluate formula dialog box, and this one is after 4 clicks. Basically, it's going to show us a piece for error, and something. Usually, it shows you what would be an error if there is one here. So, going through there, if you find an error, it's going to tell you that after you hit evaluate, it'll say boom error, and it'll tell you why. Okay. Let's see. Now we have error checking. So if we do find an error, we can use error checking. This button provides an automatic means of checking for mathematical errors within formulas in a worksheet. Now clicking on the error checking button causes Excel to check every formula in the sheet for calculation errors. If an error is found, the error checking dialog box appears. Okay. So this is kind of the error checking dialog box for a division by zero error. So it'll pop up and it'll say, hey, you know, there's an error in cell such and such, and you're dividing by an error. In this case, dividing by zero error. Okay, so so from this box of formula, you can actually edit the formula. Okay, so you can edit the formula, you can get help on it, show the calculation steps, you can ignore the error if you think it's okay. So there's a lot of things you can do, and this is really helpful when you have really large models where not all the cells of the model are actually visible, because sometimes you're going to have a huge model, only a few cells are going to be visible, the rest of them are kind of all hidden in the background, and so this will actually help you evaluate if there's anything wrong. Now we also have a watch window. Okay, so the watch window located in the formula auditing group allows the user to observe the values of cells included in the watch window box list. Now this is again is useful for large models when not all the model is observable on the screen or when multiple worksheets are used. So you can use multiple worksheets, multiple tabs, and the user can monitor how the listed cells change with a change in the model without searching throughout the worksheet or changing from one worksheet to another. So if you change one number like the quantity, what does it change throughout the whole a set of worksheets, and it's really helpful there. All right, so this is the watch window for cell B17 of the Gambrel manufacturing model, and it shows you what is changing. It changes this value, and this is the formula. Okay. So basically, how did we get to this? So what we did was we want to add the following steps to cell B17 for the watch list. So we're going to click the formulas tab in the ribbon. We're going to click the watch window in the formulas auditing group to display the watch window. We're going to click add watch. Then we're going to select the cell we want to add to the watch. In this case, it's the B17. And so as shown here, the list gives the workbook name, the worksheet name, the cell name, if there's one used, cell location, cell value, and cell formula. Now to delete a cell from the watch list, you basically click on the entry from the list, and then click on the delete watch button that appears in the upper part of the watch window. So if you want to get rid of this watch after a while, you just click it and then click the delete watch. Now this watch window allows us to monitor the value of B17 as we make changes elsewhere in the worksheet. So this will come up and we can maybe make a change on the quantity or a change on price or change on this or change on that, and it will show us the new value here, okay, basically. So if we had other worksheets in this worksheet and workbook rather, we could monitor changes to the B17 of the worksheet even from those other worksheets. Now, if the watch window is observable regardless of where we are in the worksheet of the workbook, so no matter where we're at, as long as we started that watch window, we're going to be able to see what happens wherever we're at. So if we make a change in one place, we'll still see this watch window. So that's the cool thing about it. So hopefully this will help with chapter 7. And again, it's quite long, but it's kind of really covering the whole chapter. There's quite a few people that wanted this for in the journal post this week. So hopefully this helps. If not, please let me know what additional items could be of use.